Hello guys, hello everyone. In this video I will demonstrate a Windows persistent backdoor. Um, it has a mechanism with hidden registry key and hidden activation file. Registry recreates and re-enables itself in case it was disabled or removed by the user. The activation file will be restored if it was deleted by the target, the user, or the antivirus. However, it will be recreated as not hidden if the user or the antivirus deletes it. Um, there is an anti-process and task stacking features that making everything run silently, consume literally 0% CPU, and I will show this as well. Here I put from me two commands for the testing to show you. And the disadvantage of this backdoor is that if the user formats the computer, the backdoor will die. It will be effectively removed. And if the persistent shell itself, it's not advised to use as a platform to execute commands on the target. Um, rather it's better to open another port on another terminal and execute from that another reverse shell and open you another shell to execute all the commands from there to avoid using the commands on the name of the vector. So let's start by listening. I will actually get a connection here. Actually, let's just reboot and see the connection that we get after the reboot. And then we will wait for another 19 seconds. The backdoor connects every reboot, connects every 90 seconds. It has more mechanism, but this is what you visually see. So in the demonstration, I will delete the registry and show you how they're being added automatically. We'll do the garbage querying. We will delete the file itself to see how it's being restored and everything. So a few seconds after the system boots, if you look at the mouse, you can see a little like it's thinking or something, and that is actually what's going on in the background. You see it? You see it now? That's actually what's going on in the background, and this is what connects us to what gives us the connection. So this is the connection after reboot. We'll just exit and wait another time, wait for the 90 seconds timer to hit again. It can be 90 seconds from now, it can be 2 seconds, but then we'll get another connection. And meanwhile, we're not wait now, we'll go directly to show you how the register looks like and everything. So the script itself, it's in this folder. I implemented it in the app data roaming. So you cannot see here everything, of course, because it's invisible, but after the connection gets, I will show you how I can verify it exists from the shell without, even though it's being hidden. So in a few seconds, we will get the shell. All the time when I demonstrate, it takes 90 seconds. It's never time 2 seconds or 3 seconds. Okay. Yeah, we will wait for it, for the shell, because I want to go to the folder. Here it is. So right now we're at system32. We'll go to env app data. And just to show, if I do ls to list, we will not see, we're in the roaming, we will not see the script. However, ls-force will show that our system API.vbs exists. The user itself also can see it. If the user goes to view, options, view, and removes this mark where it says recommended, and yes, and apply OK. So suddenly you see some files in the desktop will appear, some invisible files, including our invisible file that is no longer invisible in the roaming folder, which is the active backdoor. The registry points to this backdoor, and then this backdoor works on reboots and every 19 seconds. So to show that the registry is hidden, you will go here to the task manager, to the startups tab, and we see that it does not appear system API.vbs. Also, we will just open the startup apps in the system settings, and it will also not appear. However, the user can view it if the user opens PowerShell or SMD and sends a registry query. To check what is the query, we will do it now. We will see that system API exists in the roaming folder, system API.vbs, this file. So what we want to do is we want to delete it. We want to imitate what the user would have done maybe, and if you found the command to remove it, well done. But also that I will do registry. It says the operation was completely successful, that the registry was removed. But if we will query again, we will see that it in fact was not removed, because this is the mechanism that works behind. We'll do it again. If actually I do register key delete and very fast I do registry query, it will not appear because it was not re-added yet. But if I do registry query a second after, it will appear. It takes it a second. So let's try to do it fast. Register key, registry delete, and registry query. No, it's too fast. So it's just not deleting the registry key. And what else? Activation file will be restored if deleted. Yeah, also the VBS, this is the registry key for the VBS. But if you just delete the VBS itself, we'll do it now. So it's also recreates him again, exactly in the same form that it was before. Totally functional and everything. We'll do it again. Delete. This time it was faster. It depends where it is in the loop. It recreates him every 5 seconds. It checks if it exists every 5 seconds and recreates if it's not. So now after it was recreated, remember that I said that it will not be created as hidden. So let's say that the antivirus removed it because it detected after a while a pattern or something, it removed it. It will simply be recreated, but this time it will not be with the hidden in system attributes. It will be just normal. It's totally visible. Means that if the user does not see it, it's okay. Also, you cannot effectively remove it. So this is the mechanism. And the anti-process stacking feature. Yeah, let's see in the user itself, because we have shell now to the target. We will prove it by sending a message. Hello from the new admin, lol. And the message will appear, of course, on the PC. So we do have shell to the PC. Let's see how much the user feels. So if the user is looking at his process, you can see actually our PowerShell script here. This is our PowerShell shell, but it takes 0% and it's very low, and in my opinion it's not very suspicious. Of course, that if the user will close it, our shell will be closed. We can do it live. Let's do it like that. Oh no. Now we'll just close it and we see that our shell immediately closes here. But I can listen again and it will get again. So yes, this is the persistent backdoor that I built. Hope you like it.